Hello, this is Philip, and here is a presentation of the EFX Render Elements suite of plugins. Basically, all of these plugins came as solutions to problems I encountered with working with render elements throughout the years. You will recognize two plugins that come free, and you can download them freely from the site, but you'll also have many additional plugins, and I will show them here. So, let's say we have a rendering like this. That's a beauty pass, and we want to recreate it. So we start with a diffuse channel, then add a lighting channel with multiply mode, add shadows, and this is where you encounter the first problem. You've got visible edges between objects because probably because of anti-aliasing algorithms during rendering, the shadows in the shadow pass do not touch exactly the edges of the objects. From what I've seen on the forums, people just deal with it and either leave it like this or render the shadow pass with the lighting pass, so they have one pass less, but avoid this problem. I decided to fix this problem, allowing you to still work with a separate shadow pass, and that's how we do it. So we have the shadow pass, apply the shadow fix, and immediately you can see the edges disappeared. What the plugin does, just expands the shadow layer 1 pixel outside. If you're okay with that, good, you're done. But you might not be okay, because first of all, the shadows here creep into objects, and the shadows here creep outside of the edges. So we basically have to tell the plugin that we want it to work only on edges between two objects. To do this, we have to supply it with two technical passes: a node ID pass that will help it distinguish between a different object, and a z-depth pass that will help it reduce the effect based on depth information. So the input 2, sorry for not naming these, but Pixel Blender does not allow it. So input 2 is an ID pass, so we select it here. And input 3 is a z-depth pass, we select it here. So now what happens? You can see that the effect has disappeared. That is because we have a tolerance of z-depth equal to 0. Basically, two neighboring pixels have to have a difference between their depths, has to be lower than this threshold for the effect to be applied. So if we enlarge this, the effect will start working. And as you can see here on the edge, the effect is working bigger and bigger, the bigger the difference between the depth of these pixels is, right? The ID tolerance is for telling it that not to work on the surface of the same object. Now you can see the shadow is here on the floor and it's still expanding. So let's tell it not to work on the surface of the same object with a tolerance of the ID pass. That should be enough. Let's try to remove these with a z-depth tolerance threshold. Now we can basically see we are fighting two effects. First, the creeping in of the shadow onto the object. We can make it disappear, but then we have an edge here. So I propose we make it disappear like this, and just then play with the opacity of the effect. Let's just reduce it a little bit. If we go to 0, it's like no effect has been applied. 1 is a full effect, and going somewhere in between lets you lower the artifacts and still have a shadow pass that looks like it's clean. Okay, then we add a global illumination pass, add, and a funny idea I had, let's add a reflection pass. Let's enhance it to make it a little bit more visible. Okay. What if you wanted a reflective surface that was, well, a little bit matte? So basically you would have to render a blurred reflection. That of course takes a while to render. Sometimes you don't have the time, because the differences between a reflection like this and a blurred reflection are like a couple of minutes of rendering to a couple of hours of rendering. So the first idea is, let's blur the path. So let's blur the reflection path. Okay, that's not bad. Apart from one detail, that we're actually blurring the reflection path between separate objects. As you can see, the blurring effects do not respect the boundaries between objects. So the whole effect of blurring the reflection is pretty visible. That's where we come in with EFX ID blur. Basically, it's a blur that distinguishes between different objects. We have to supply it again with a material ID pass, and then we can blur the reflection. As you can see, the reflection blurs as before, but the blurring does not cross the borders of an object. Unfortunately, this will result in artifacts on edges of objects. Let me get back to it later, because this is a problem that you will always encounter when you're trying to work with render elements. You have a couple of these blurs, so let's distinguish between them. These three blurs are basically exactly the same. The difference between them is the maximum blur amount allowed. So this filter can blur at maximum of 10 pixel radius, this 20, and this 40 pixel radius. Why I did it this way is, again, because Pixel Blender does not have a built-in blur function. I had to write it from scratch. And apparently the maximum radius of the blur influences the speed at which the plugin operates. Just to show it, if we apply the 10 pixel blur, it thinks a little, but then it's ready to go, right? If we apply the 20 pixel blur, it thinks a little longer, and then it's ready to work. But the 40 pixel blur will unfortunately think a while. It's still thinking, preparing. I have no idea what it's doing actually. It's probably initializing the filter. And as you can see, the difference in time it requires to initialize the filter is enormous, especially on HD footage. That's why basically you've got three different filters, and just use the amount of blur that suits you and nothing higher. Yeah, now it's initialized. So again, and it happens that it has to re-initialize from time to time when you pre-compose a composition or something, and you have to go through the waiting all over again. And once again, if you apply the 10 pixel blur, which is more than enough for many cases, it works straight away. So that's why you have three versions. Next we have a EFX ID zenith blur, which is basically the same, but you have additionally a second input, and the second input waits for a zenith map. Basically, imagine you have a big reflective object like a torus knot or a character. We had a big blobby snake, and basically it's one mesh, so it's going to have a single ID all over, and this filter will not really work at all on it. It will be acting just like an ordinary blur. So here you can additionally to the ID pass supply a zenith pass, which will allow you to set a zenith tolerance for pixels that if they fall below this threshold, they will be blurred together. If the difference in z depth is higher than this threshold, they will be considered an edge of an object, and the blur will not cross over the edge. That's a solution to the situation where you have only one object, but big, intersecting with itself. So other functions we have, this is basically a way to make a blur more blurrier, picking between, I don't know, a Gaussian blur and a box blur or fast blur algorithm. So without changing the radius here, you can change the gamma and have a different shape of the blur fall off. And of course ID tolerance here is helping you just add some pixels that are on the edges, and this is a way to remove some of the artifacts on the edges. Be careful not to go all the way up to 1, because you'll just do a normal blur then, right? It will tolerate all the IDs as one ID, and you will go over the edges with the blur. So let's now go all the way up with this. I promised you we would try to deal with the edge artifacts, and that's what we do now. Let's add an adjustment layer and add a filter that's called edge blur. Again, supply the node ID mat, and what edge blur does, it basically allows you to find edges between objects. You have 3 options: show edges, show soft edges, that's a little bigger and softer of course, and the final. And what it does, it finds the edges, and within these edges it blurs the image. So as you can see right now, we can blur the edges less, more, and remove the artifacts. Still an ID tolerance here, and the mix amount is just the way to back off the effect to 0 or stay with the full effect. Okay, so just to recap, we have a diffuse pass of a rendered scene, add lighting. Let's add global illumination first. You can color correct the lighting pass in any way we want. Right? Then we add the shadow pass. As you can see, we've got the artifacts. Let's apply a shadow fix to this. That's better. I don't think we even have to supply the additional channels here. It just looks okay. Okay, so just to be clear, let's supply them. Background object ID and background z-depth. Increase the z-depth tolerance, and there, it looks pretty clean. We can add some z-depth tolerance here, so that, okay, looks cool. Ambient occlusion, why not? Reflection, just like before. Let's blur the reflection. Let's blur it with, this time with both, since z-depth and the node ID, since our node ID, here it is. For this object will be well, just it's one object, right? And we don't want to cross these edges with the blurring. So let's add EFX ID z-depth blur 10, of course. Let's add ID pass, z-depth pass. And now let's play a little with blurring. It's getting blurred, very nice. Let's increase the ID tolerance so we get rid of the jagged edges here. Let's decrease the z-depth tolerance. You see the difference here on the edges. If we have no tolerance for z-depth, there is no blurring through the borders of the edges. So let's increase it a little bit. And there we go, we have clean blurring. Just so that we see the difference, let's snapshot it. Okay, let's add a blur filter. Let's blur. Okay, and now let's. You see it? This is a blurring of the reflection pass with a simple Gaussian blur. You can see it going past the edges of objects, and this is a blur with the ID blur effect. And to me, the difference is significant enough to justify the use of this filter. Right, so, okay, let's leave it as it is. We still have artifacts on the edges of the objects, but we will deal with them in a second using the ID edge blur filter, right? Okay, so let's pre-compose this scene. I've done it here, and I want to show you some filters that are connected with selection. So we have a velocity select filter. Let's do this on this layer. We add a velocity select, supply a velocity layer. We don't have a velocity layer. Okay, so we need a velocity layer. Background velocity layer. Thank you. If you will wonder, it looks like this because only these objects are moving. Let's get back to, you know, for now I will just remove the blurring on the reflection pass, as it will just work a little faster with our project. Okay, we supply the velocity path here, and it's actually fun because it's like this. Here you indicate what direction the objects you want to select are moving. So here the object's moving upwards, here the object's moving downwards. Of course, here you can select the one of three velocity pass formats. These are called after the formats in final render, but I'm pretty sure that all other renderers will match one of these. So these objects are moving downwards, these objects are moving upwards. Since this is really precise to tell that you want a moving object moving in exactly in 2 degrees from the vertical axis, we have a directional spread here and directional spread follow. So we know they're moving upwards, right? But let's set it up like this. They should be moving this way, but because we have a direction spread of 15 degrees, they are also selected. So we basically have now the direction of -20 degrees plus -18 degrees left or right. And the other thing is that if we lower the direction spread, and we have direction spread fall off, so basically you can include with a fall off some other directions as well. It's just a soft selection, right? So everything in -20 degrees plus -9 degrees will be selected fully, and everything within these angles, so 20 degrees plus -9 degrees and plus -8 degrees will be selected with a soft selection. So let's select these fully. If you want to select the other ones, just tell it to select the objects that are moving in the other direction. We also have a selection of minimum velocity value and maximum velocity value. So we want to select objects that move faster than 0.2 and slower than or equal to 1. Right, so since these objects are all moving with the same speed, and the velocity path has been calibrated for this speed, so they're actually moving with a speed of 1. If we lower it, you see they disappear. And again, we have these artifacts on edges of objects, but that's because of anti-aliasing in the renderer. We can get rid of them later using the alpha streaks filter. What if you'd want to select objects that move with a certain speed, velocity, and you don't really care which direction they move? Well, just zero out the direction spread and directions fall off, and they stop working at all. Now everything that's working is just minimum value and maximum value, and as you can see here, now we are selecting only the moving object. But let's get back to selecting the object moving upwards. Okay. So we can do some color correction on them. Why not? Also, we might do a matte choker on them and increase gray level softness so that it's a softer edge. A little less. Oh, there we go. Nice correction on just moving parts. Additionally, we also have an ID select. So select ID select, supply it with ID pass, background ID pass. Thank you. ID pass, reviewing the ID pass. Let's select all of the object in front. So this ID, this ID, this ID. Okay, well, let's just leave it like that without the teapot in the front. Final. We can play with the tolerance values here a little. I don't think this will give us much, except maybe at some point selecting more objects. So let's not do it, and let's just add an alpha streaks filter, 2 pixel border. Let's duplicate the filter, and done. We have a selection of the front object. Again, color correction on them. I don't know, let's do it this way, and maybe this way. Why not? Cool. One more thing. Actually, talking about objects in the front, why not select them based on a zdepth pass? So we have zdepth cut filter, supply it with zdepth channel, and here's what we have: front full cut threshold, front no cut threshold, back full cut threshold, and back no cut threshold. So front, it's defaults to 1, so if we dial it down, you'll see things disappearing in the front. We have a no cut threshold as well. If it goes below the full cut threshold, you can see a soft selection here. The same way, the back full cut threshold is set to 0. If you increase it, you'll start seeing things disappear from the back, just like that. Okay, and a no cut threshold is again a soft selection for this. An offset just keeps the selection as it is, but offsets it to the back or to the front. So you can create a zenith wipe through the scene like this. The mode, I'm sorry, I will rename this. It should be invert. So of course you can invert the effect. So you can cut out the objects. So let's leave it like this. We want to select these guys, so we don't want to lose anything in the front. We just want to cut out the back. Really. Okay, like this. And let's do a soft selection here. Okay, because for some reason everything in the front gets really blown out. Right, why not? Again, we see the issue of borders. What we can add an adjustment layer, edge blur, supply it with object material LED, and there we go. We have successfully blurred the edges of all objects, reducing some artifacts. I hope you can see it. Reduced, full artifacts, reduced, full artifacts. We can also blur it a little bit more, hoping that that will remove the artifacts even more. Maybe less. Okay. You do lose some sharpness of the image this way, but I think it's a lot less visible than the artifacts we get after playing with render elements. So, you know, just to remind you, you can also use this filter as a selection for the edges, one or the other, and just use it as an alpha track matte for your own adjustment layer. And if you think you can do better job at blurring the edges, be my guest. You can use your own methods. Okay, so we've got this. What else can we have? Let's say we've rendered separately a layer of a walking bug, right? Unfortunately, we forgot about matte shadow materials, mask, or anything that would allow us to composite this bug into the scene. But since we're in the habit of always rendering the technical passes, we have a zdepth pass on it. So let's use an EFX zdepth compose filter. Input 2 is for the current layer's zdepth, so this zdepth. Input 3 is for the zdepth of the layer you're trying to mix with, so background zdepth. And now you can see these layers mix properly. Let me just remove some of these so that we can view it a little bit faster. As you can see, the bug walks behind. I just removed the edge blurring filter, so I hope this will be a little faster. As you can see, we have for the background we have just one layer, one rendering. It was all in one go, and we were able to composite a second layer of the bug inside this background layer between the objects, thanks to just the zenith channels. Here also you have basically an offset value where you can pull the layer in front or a little bit more to the back, it all depends on what you want to do. One thing I found, and you should remember that for the bug here, because it's being rendered on nothing, on transparent background originally, you're better off with rendering a zenith pass that is not anti-aliased. This one's anti-aliased and this one's not. It's uglier, but the reason for this is that this anti-aliasing is actually also depth information for the computer. It's no longer this nice gray, it's gray mixed with black, so basically it seems like these edges are further than the rest of the object. So if you replace the not anti-aliased layer with anti-aliased, you'll see a very ugly thing. You can see that these edges were actually considered to be way in the back, so they disappeared behind the wall. If you move the entire thing forward, you can see we're getting back these edges back. Unfortunately, there's no way around it. Anti-aliased data again in these technical passes is false data, and please remember to in these situations render a not anti-aliased pass. That's one thing, and also something that's, I'm hoping, really logical. For this to work properly, you should render the zenith passes for the background and for the bug with the same settings. So the front plane and the back plane should be at the same depths, so that those two depth passes make sense together. They describe the same space. Okay, one last filter we have. It's the EFX render elements zenith shadow. If you have a 2D layer and in the background you have a 3D rendered environment, and you would want to throw a shadow from this 2D layer onto the background to make it match, well, the background basically to be displaced, here's a simple trick. Let's say we have this background rendered in 3D, we have this front layer, let's duplicate it. So now we have only this layer. Let's color it so it looks kind of like a shadow, probably more with desaturation. Okay, and now remember we still have a zenith pass for this CG background. Let's apply the zenith shadow. Select the zenith pass of the background, and now what you can do is displace the layer based on the zenith data, horizontally or vertically. You can reduce the opacity, you can set the fall off for the opacity, is it larger or smaller, and also you can even blur the shadow the further it goes. And like in other plugins, you have the blurring curve to set up as well. And you also have a way of moving the shadow altogether in one way or the other. So let's reset it, enable the front layer. Now as you can see, we're throwing the shadow onto the background basically. Of course, what we can display here is the final compositing of shadow, original shadow, so this layer, and the zenith shadow, so the zenith layer, so this. We of course want the final one, and as you can see, everything plays nicely.